Hello everyone, today we are going to analyze this overhanging beam. In this beam there are two overhangs. On the left side we have the overhang AC which is 2 meter in length. There is a uniformly distributed load 12 kN per meter, and in the middle of overhang there is a point load 22 kN. On the right side there is a overhang EF which is 2 meter in length. Here there is a uniformly varying load which varies from 0 at F to 24 kN per meter at E. The portion CE is simply supported. In the point D there is a concentrated movement 20 kN meter. It is acting in the clockwise direction. To find RC, let us take moment about E. In this case we have to follow right hand side rule. The UDL is acting in the anti-clockwise direction, so it will be negative. The area is 12 into 1 plus 1, so it is 12 into 2. The centroid distance about C is 2 upon 2, but we are taking moment about E, so we have to add the remaining distance which is 3 plus 2, so it will be 5. This point load is acting in the anti-clockwise direction, so it will be negative, and the distance is 1 plus 3 plus 2, so it will be 6. RC is acting in the clockwise direction, so it will be positive, and the distance is 5. This movement is acting in the clockwise direction, so it will be positive. The UVL is also acting in the clockwise direction, so it is also positive. For the UVL, we have to multiply the area with the centroid distance. We know the area formula of a triangle, half into BH. Here the breadth is 2 and the height is 24. So this is the area. The centroid distance about E is 1 upon 3 into breadth. The breadth is 2, so it is 1 upon 3 into 2. In this way for RC we will get 48 kN. To find RE, let us take moment about C. In this case we have to follow left hand side rule. The UVL is acting in the clockwise direction, so it will be negative. This is the area of the triangle, and about E, this is the centroid distance. But now we are taking moment about C, so we have to add the remaining distance which is 2 plus 3, so it will be 5. RE is acting in the anti-clockwise direction, so it will be positive, and the distance is 2 plus 3, so it will be 5 RE. This movement is acting in the clockwise direction, so it will be negative. This point load is acting in the anti-clockwise direction, so positive, and the distance is 1. This UDL is also acting in the anti-clockwise direction, so it is also positive. This is the area, and the centroid distance about C is 2 upon 2. For RE, we will get 22 kN. Alternatively, using this rule, we can find RE very easily. RB and RE are acting upwards, so both of them are positive. The UDL, point load, and UVL are acting downwards, so all three of them are negative. For the UDL and UVL, we have to take the area. This is the area of the UDL, and this is the area of the UVL. For RE, we will get 22 kN. Using the right hand side rule, let us find the shear force values. Shear force at A will be 0. Let us find the shear force at just left of B. Up to just left of B, we have the UDL 12 kN per meter. It is acting downwards, so negative, and the area is 12 into 1. In this way, we will get minus 12. To find the shear force at just to right of B, with this we have to add this. This load is acting downwards, so it is also negative. In this way we will get minus 34. Let us find the shear force at just to left of C. With this we have to add the UDL, this one. It is acting downwards, so it will be negative. The area is 12 into 1. We will get minus 46 finally. To find the shear force at just to right of C, with this we have to add this. It is acting upwards, so it will be positive. In this way we will get 2 kN. Shear force at just to left of E also will be 2 kN. To find the shear force at just to right of E, with the true we have to add this. It is acting upwards, so positive. In this way we will get 24 kN. To find the shear force at EF, let us use the left hand side rule. Anyway, the shear force at EF will be 0. Here you can see the shear force diagram. To find the bending moment values at B and C, let us use right hand side rule. Let us find the moment at B. This UDL is acting in the anti-clockwise direction, so negative. The area is 12 into 1, and the centroid distance about B is 1 upon 2. In this way we will get minus 6. Let us find the moment at C. UDL is acting in the anti-clockwise direction, so negative. Area is 12 into 2. and the centroid distance about C is 2 upon 2. This point load is acting in the anti-clockwise direction, so negative, and the distance is 1. In this way we will get minus 46. To find the moment values at E and at D, let us use left hand side rule. Let us find the moment at E. This UVL is acting in the clockwise direction, so negative. We know that this is the area and this is the centroid distance about E. Finally we will get minus 16. In the point D, there is a concentrated movement. So we have to find the movement 2 times at just right of D and at just left of D. First let us find at just right of D. The UVL is acting in the clockwise direction, so negative. This is the area and this is the centroid distance about E. Then we have to add the remaining distance up to D, which is 2. This reaction is acting in the anti-clockwise direction, so positive, and the distance is 2. We will get minus 20. To find the moment at just left of D, with minus 20, we have to add this. It is acting in the clockwise direction, so it will be negative. In this way we will get minus 40. We know that in the points A and F, the moment will be 0. Here you can see the bending moment diagram. Now we are going to end this session. Thank you for watching this video.